The independent variable, we talked about this last chapter a little bit, is a variable that affects the value of the other variable. And it's always placed on which axis? X, okay? Or you can write horizontal. Good, horizontal or X are both acceptable. And you can pick any values for it. When it says can take any values, it means you can just pick values. So if I'm looking at time and earnings, I can just pick any value of time, and I can calculate someone's earnings if I know their rate of pay, okay? Dependent variable is a variable that's affected by some other variable. So it's affected by the independent variable. Earnings is affected by how many hours I work, okay? And so it depends on the independent variable, and it's always placed on the y-axis or the vertical axis. And in a table of values, where is the independent variable always located? On the left side or the right side? X is always on the left in a table of values. The independent variable is on the left, and the dependent variable is on the right, okay? Okay, we're gonna look at this chapter. What's an outlier? Okay, so there might be a scatter plot like this, where there's a bunch of data that looks like it has a trend. We're gonna talk about the trends, a relationship, and then all of a sudden there's a point that is separated from that. Okay, there's a point that's way apart from the trend. That's called an outlier, and we're gonna talk about that later in this chapter, so I'm just gonna leave that for now, but that's called the outlier, okay? So it's something that does not follow the trend in data. So there could be a reason why it doesn't. Okay, so if you wanna add here, does not follow the trend in data. Okay, so now we're looking at relationships / correlation. So whether something has a strong relationship. So strong relationship, just how it sounds, the points are close together. If you were to draw a line of best fit, the points are very, very close to the line of best fit. Okay, so if that's strong, what's weak?
Two variables vary at rates that...
Okay, so opposite of strong, there still will be a visible pattern, but the points will be somewhat scattered. So there's still a pattern, but it's not very strong. And then we've already done this, a positive relationship if the line of best fit is positive. And what's negative? If the line, you draw the line of best fit, if it's negative, so if it's decreasing. Okay, so no trend means there's no pattern, and the points will look completely random. They're just scattered all over the place. Strong negative. Who else got strong negative? And like they said, strong is if it's a tight oval. So I can draw like an oval around this, and it's very tight. That's what they mean by that, tight oval. And if you were to draw a line of best fit, no, for the strong one, it's tight. Okay? What about B? What did we get for B? Strong, positive, correct. The points are increasing, and they're very close together, so it's strong. What would you say C is? Correct. Weak, positive, and this is a fat oval. There you go, there's your fat oval. Weak, negative, again, it's a fat oval. If you draw your line of best fit, it is decreasing. This one was increasing. And then for E, Loren, what'd you say for E? No trend, good. Now, F I didn't really talk about in the description. We're gonna get into that in 6.3. Is this a line or a curve? Curve. So this is called a curve of best fit, okay? Strong, good. What they're asking is, who is represented by each point on the scatter plot? This is a scatter plot. So you want to see who is, number 7 would be a low height, young, and a low age, because it's the lowest for height and the lowest for age. Gavin, okay, we'll do that one together. Gavin is the baby. This is Gavin. I know it's hard to read. The y-axis shows age, so if you look here for a sec, these two people have the same age, but one of them, number 2, is taller The height is greater than number 1, but they're the same age. So which two people do you think look like they're the same age? Okay, Alice and Dennis look like they're the same age, but one of them's taller. Who's taller? So would Alice be number 1 or 2? Good. Alice and Dennis would be number 1. Because number 1 is closer to 0, so he's not as tall for the x-axis. Okay, number 3 is the next oldest. Freda, however you want to say her name. So we've already done Gavin. Frida. Okay, and then, so we have another similar point here. Number 4 and 5 are the same age, but one of them's taller. Who looks like they're the same age? Okay, Errol and Brenda are the same age, but one of them's taller. Who's taller? So Errol's number 5, and Brenda is number 4. And then last but not least, number 6, not very tall and not very old. That one's the easy one. Kathy. Yeah, and then Gavin. Good. Okay, so for A, do you think age has a strong positive correlation with height? Do you think there's a strong relationship between age and height? As you get older, does your height increase? Yes. Do you think the variables were placed appropriately on the axes? Do you think age should have been Y or should it have been X? Does your height depend on your age or does your age depend on your height? So this was wrong. That's why it was hard to read. This should have been the other way around. Okay? Age should have been independent and height is dependent. Your height, I mean, in most cases, in some cases there might be an outlier where there's a situation where you're not growing, right? Okay, and do you think weight versus age would be a strong positive correlation? Do you think as you get older, your weight increases? Yes. From birth till now. Let's see who can come up with an answer for D and E. Can you think of a variable that has a strong positive correlation with age? Okay, so we're saying from birth until now. How old are you guys? 15, 14? Your shoe size. Perfect. That's a good example. Shoe size. Okay. And what about a strong negative correlation? What decreases with age?